All right, so we're going to be covering solutions to systems of equations. Systems of equations is just fancy for two or more linear lines, okay? Two or more linear lines. So right here it says any blank x and y on a line is a solution to the line. Any ordered pair or point, right? Ordered pair is just fancy for a point. So any point x and y on a line is a solution to that line. Okay? If a point xy makes the equation true when you substitute it, so whenever you plug in that x and whenever you plug in that y into your equation and it works out, right, then we say it's called a solution. So put right here, if any point xy makes the equation true when you plug in those values, then we call that a solution. A system of equations is a set of one or more linear equations with the same variables. The solution to a system is the point of intersection. What's intersection mean? What does intersection mean? Where they what? Where they cross. Okay, very good. Where they cross. An intersection point lies on both lines and makes both equations true. So in order for that point to be called a solution, it's got to be on both lines and it has to make both equations true. So let's look at some examples. All of these are going to be notes and you're going to have plenty of problems to do on your own, okay? It says, is 3, -3 a solution to that line? And that line is y equals -2x plus 3. And we're supposed to prove it graphically and algebraically. Okay, so this is what that means. So let me first check that they graphed this line correctly. Okay, and let me see if I can zoom in. Just broke it. I don't know why it's upside down. Hold on. It's because I can't zoom in when you're recording. There we go. Let me see if I can. There we go. Is that a little better? All right. So we're going to check first if this equation was graphed correctly. Remember the way we graph slope-intercept equations? You always start here, your y-intercept. So I'm going to check my graph. Did they put a dot at 3 on the y-axis? 1, 2, 3. Yes, it's right there, right? And then you use your slope to get more points. Okay, so for example, right here, my slope is -2, which we know can be written as -2/1. The top number is your rise, and the bottom number is your run. So I'm going to use that to see if that line is graphed correctly by doing this. I put my pencil on the y-intercept, and I go down to 1, 2, and I run 1. And yes, it's crossing there. And then I do it again. Down 2, run 1. Down 2, run 1. Down 2, run 1. Okay, so yeah, it's graphed correctly. Now the question says, prove that 3, -3 is a solution. Well, remember, in order for it to be a solution, it's got to be in the line, right? So how do I do that? Well, I just have to go check if 3, -3 is one of these points on my line. So let's see. 3 is my x, -3 is my y. So here's your x. You always do the x first. positive 3, and then negative 3. Ah, right here. Did the point land on the line? Yes. So we can say that 3, negative 3 is a solution to that line because it landed on the line. That's how you prove it graphically. So right here, I'm going to label it, or you can highlight it. Okay, I don't have a different colored pen with me right now, but I'm just going to make a little note. This is my 3, negative 3 to show my teacher, hey, that's how you prove it graphically. It's on the line. Okay. Now, algebraically means that you have to plug in your numbers into the equation. So I'm going to take my equation, y equals negative 2x plus 3, and I am going to plug in the x, which is a 3, and the y, which is a negative 3, in here. Okay? So who's my y in this point? Which of these numbers is the y? What kind of 3? Remember, the first one's always the x? Yeah. So this is a negative 3. And then I'm just copying down what the equation has, right? But on the x and the y part, that's where I'm plugging in my numbers. Who's the x? The 3. And then, of course, there was a plus 3 right here. And then you got to check. Does the problem side right here equal the answer? Well, let's see. What operation's happening here? When numbers are next to each other, what is that? Adding, subtracting, multiplying, or dividing? Multiplying, right? So what is negative 2 times 3? Positive or negative? Negative, right? So I have negative 6, and then I still have this plus 3 here. What do you get when you do negative 6 plus 3? Negative 3, yeah. So this is negative 3. Did I get the answer that was there already? Yeah. So that's how you prove it algebraically. That when I plugged in my numbers, it worked. Okay, so we call that a solution. Questions there so far? Okay. Let's go to another example. Same type of problem. Is 6, 9 a solution to the equation that's already graphed for you, y equals 2/3 x? And prove it graphically and prove it algebraically. So here we go. Who's your y-intercept in this equation, guys? 0. Very good. So I'm going to just make a little note to myself that it's a 0. So that's why you see that they started at 0. Now your slope is 2/3. Remember, the top number is your rise, the bottom number is your run. So they're telling you from the 0, go up 2 and run 3. So up 1, 2, and then run 3. 1, 2, 3. Yep, I'm landing on the line. Up 2, run 3. Up 2, run 3. So yeah, they graphed it correctly. Okay, now I need to check, is 6, 9 a solution? Well, how do we know? What do we have to do to prove it? Yeah, make sure it's on the line, right? So remember, 6 is your x, so I'm going to go 6 right here on the x, and then I'm going to go up to the 9. 9 is over here. So this is 6, 9. Is 6, 9 a solution to that equation? Yes or no? No. Why not? Because it's not part of the line. It didn't land on the line. Remember, this guy can be a solution. This point can be a solution. This point can be a solution. So can this one, because they're all on the line. But any point that's not on the line, that's not going to be a solution. So, nope, not a solution. And there's my proof. It did not land on the line, so it's not a solution. Now let's prove it algebraically, even though we already know that it's not going to work, right? But let's prove it. So I'm going to take my equation, I'm going to plug in the x, which is a 6 in here. I'm going to plug in my y, which is the 9. And then all you have to do is look at the problem part and check if it's giving you a 9. Well, 2/3 times 6. You remember how to multiply fractions? 2/3 times, remember to put 6 over 1, right? And then just multiply across. What's 6 times 2? 12, right? What's 3 times 1? What's 12 divided by 3? 4. Did I get a 9? Nope. Didn't give me that 9. So false. There's your proof. Okay, 6, 9 is not a solution to that line because it did not land on it. So obviously it's not going to work when I plug in the numbers. Okay. So now they're saying, okay, you seem to get it, right? So now let's make it a little bit tougher. I'm not just going to give you one line at a time. Now I'm going to give you a system of equations. Well, what does that mean? It's just fancy for, let me give you 2 equations at the same time, and let's see if you can find their solution. Okay, so let's see. Here are my equations. I want to know if there is a solution. And for this one, because really on the STAR test, you're not going to have to do the harder part, which is to solve it algebraically by plugging in the numbers. They won't ever ask you to do that. They'll ask you just to know on graphs. Is it landing on the line or not? Okay, so we're not going to do algebraically here on these examples, okay? So I want you to cross this out. So we are going to check if they graphed it correctly, first of all, because they could have made a mistake, right? So I'm going to start with the first equation. My first equation has a y-intercept of -3. So -1, -2, -3 right here. And then a slope of -1/2. You see that negative? You either have to give it to the 1 or you have to give it to the 2, but it does not belong to both numbers. It only belongs to one of them, okay? So I always like to give it to the 1 on the top because that's going to tell me to go down 1. And then the 2 is going to be positive, so I'm going to go to the right, okay? So I'm going to go right here. Down 1, right 2. Down 1, right 2. Down 1, right 2. Yeah, they graphed it correctly. I'm just proving here to see if they're graphing it correctly. Not yet. -1 is the y-intercept of the other one. So here's my -1. And the slope is +1/2. So +1 means to rise 1. 2 means to run 2. Rise 1, run 2. Yep, that one's graphed correctly. And the reason why I'm just checking, obviously all of these are gonna be graphed correctly, right? But the reason why I'm checking it is because you're gonna have to graph equations. So I wanna make sure, it's an emergency or what? A little bit, hurry. You're gonna have to graph some equations on your own in the independent practice. That's come I'm just practicing so that you know how to graph equations, okay? So let's find a solution. First of all, are the lines even crossing? Are they crossing each other? Yes. How many times do they cross each other? Remember, there's 3 answers to that. Either they're going to cross each other once, they're not going to cross at all because they're parallel lines, or they're going to cross everywhere because they were the exact same line and they landed right on top of each other. So how many times are they crossing? Once. Very good. So I want you to make a little note here. This system has one solution. Now, what is it? How do we find that one solution? Where do you find the solution? What's the definition of a solution? The point of what? Where is it? Right here. Can you see it? Intersection is fancy for what point are they crossing at? Remember, a point, it's made up of an x and a y. So give me the x and y values. Give me the ordered pair that this system is crossing at. Very good. They're crossing right here, guys. Okay, so that point is -2, -2. That's it. So when they ask you, what is the solution to this system of equations? Fancy question for graph them, tell me if they cross, and then give me what order pair they're crossing at. That's it. That's all you have to do. Okay? Let's go to the next one. I'm sorry. You need, oh, sorry. Ready? Are you... Can I move it now? Okay. Here we go. The two graph lines on the coordinate grid each represent an equation. Which ordered pair represents a solution to both equations? All right, well, first let's find out the equations, okay? Let's start with, I'm going to call this line 1 right here, the one that is going down like this. Let's call that line 1. Let's find out that equation. Can somebody tell me the y-intercept of that equation? 5. Very good. It's crossing at 5. So I'm going to make a little note here. My y-intercept is a 5. Can somebody start here at the 5 and do rise over run and try to figure out the slope there for me? What is the slope of that line? If I'm right here, how much do I have to rise and run until I land back on the line? Rise and run until I'm back on the line. So if I go, how much? 1, 2, 3, 4. No, not 4. 3, right? 1, 2, 3. So I'm going to go down 3. So what kind of 3 is that? -3. And then I'm going to run how much? Once. So what's my slope? If I rose 3 down. So 3 down. And then I ran 1. What's another way of just writing -3 over 1? -3. So let me write my equation. Y equals m. Well, we found out m is -3 x. And then my b was a 5, so plus 5. So there's my first equation. Now let's focus on equation number 2. Somebody tell me the y-intercept of equation 2. It's very good. It's crossing the y-axis at 1. And who can find the slope of the second equation? How much are you rising and running to get back on the line? How much do I have to rise and run to get back to the line? Jorge, how much am I rising and running to get back on the line? Well, that's for this first one. We're done there. Now we're looking at this one. If I'm standing here at the y-intercept, how much do I have to rise and run to be back on the line? We don't know how to find slope.
Rise 4.
Okay, if I rise 4, 1, 2, 3, 4. Okay. And then run how many? How many?
4.
Very good. He said, go ahead and rise 4 and run 4, which he's right. Look, 1, 2, 3, 4. 1, 2, 3, 4. Am I back on the line? Yeah. So 4, 4 is really what? 1, right? So then give me the equation. Now you know your B, now you know your M. What's your equation going to look like and sound like? Y equals? So who's the M? No. 1x. And then? Plus 1. Very good. So this you do have to know how to do. If I give you 2 lines graphed, you do need to be able to be giving me the equation. Okay? All right. So we got the equations of the lines. Now I'm going to ask you in a very fancy way, what is the solution to this system of equations? AKA, do these lines intersect each other? And if they do, at what point? That's all it means. So are they intersecting each other? Yes. So we say that, yes, it's got one solution because they do intersect each other and I see them only crossing once. So it's going to have one solution. And where are they crossing each other? What is the ordered pair that they're crossing each other at? The other way around. 1, 2. Very good. So 1, 2. There's your answer to that system. Okay? Questions there? Okay. So I'm going to skip the bottom question because I feel we need more practice right here with this one. From where? From where? Hurry. Here, give this to Mr. Gonzalez. Okay. Remember, those of you that are here, right, we're still going over notes. So if you missed something, you can still watch this video at home because I am going to upload the link to this video. And these notes, tomorrow when you come in, Mr. Gonzalez is going to check your spiral and be like, okay, let me see the notes from yesterday. Are they completed? Easy 100. Okay. Then the video we did together, easy 100. And then the independent practice is going to be another grade. So already just for today, 3 grades for the second 6 weeks. Okay. These are the last notes. So this is like your chance to ask questions if you're still stuck. Your independent practice. Yeah. Okay. All right. So let's look at these. It says Ace and Annie graphed linear equations on the same grid as shown below. Use their graphs to answer letters A through D. All right. It says write an equation to represent each person's line. So let's look at Ace. Here's Ace. This is the line for Ace. They're telling me go ahead and find the y-intercept and the slope because I'm going to need you to give me the y equals mx plus b equation. So give me the y-intercept for Ace. What's the y-intercept? Where is it crossing the y-axis? Remember, this is the y-axis at 2. Very good. So that's super easy to get. Okay. Now you have to put your pencil at 2 and decide how much are you rising and running to make sure you're back on that line of Ace. And you can pick any point, right? Like, I just want to land back on the line. So let's say I just want to land back here. How much am I rising?
2 over 2.
2 over 2. What's 2 over 2 really equal? 1, right? So I'm going to put my slope as 1. So all I got to do is rise 1, run 1, rise 1, run 1, rise 1, run 1. I'm always back on the line if I just rise 1, run 1, right? So my slope is 1. Now give me the equation for Ace. What's it going to look like now that you know M and B? Remember, you're just plugging in M and B here. So what's it going to sound like? Everybody agree? Y equals 2x plus 1?
No.
Who's M? The 1. So 1x plus 2. Be careful. That's why I like to label them. Yes. So now let's go to Annie. Same thing for Annie. I need to find the y-intercept. And right here, 8. Very good. And the slope. And it doesn't matter what other point you want to get to. Okay, so for example, I might say, you know what, I'm going to rise and run until I get to this point. Somebody might decide to be like, you know what, I'm here, but I want to rise and run to get to this point. It doesn't matter. You're going to end up with the same slope because remember that you can simplify fractions, okay? So, what's his name back there? What's your name? What's your name? Huh? Alejandro, find the slope for me. So if I'm here, how much do I have to rise and run to get back to the line? Well, let's figure it out, okay? Let me give you an example. If somebody were to tell me, Miss, go down 3 and run 2. Am I back on the line? No. But what can I do?
Rise.
Down how many?
1.
1. And run how many?
1.
1. And since you went down 1, guess what kind of 1 that is? Negative, right? So then the slope of this one is what? Negative.
-1.
-1. Very good. So -1. Alejandro, pay attention. So now, Alejandro, now that you know B and M, give me the equation for Annie. Remember, you're just plugging in the M and the B, and Y equals MX plus B. So let Alejandro answer. Okay, so always make sure you're looking here. This is slope intersection. I need the M number first and then the B. So look at right there what we wrote. Very good. Very good. Much better. Okay. So Isaiah, make sure you keep watching the video at home to fill in the notes, okay?
Okay.
Here you go. Here you go, Isaiah. All right, look at letter B. List the ordered pair where the lines intersect. Are these lines intersecting, guys? Yes, where? At 3, 5, right here. We say that this is one solution because it's only crossing once, and it's crossing at 3, 5. Is the point above a solution? Duh, because we said solution is where the lines intersect. So we're going to put right here, yes, because it is where the lines cross. And I think it's just asking, is the point a solution to Ace's and a solution to Annie's? Well, yeah, that point is part of both. That's why they're crossing there, okay? Alex, close your Chromebook. You don't need it. Time to do math. Don't worry about the time. It's not time to go. All right, here we go. So we're not even going to answer this bottom part. It's repetitive. Of course, it's also a solution to Annie's because it's part of Annie's line. It's part of Ace's line. So it's part of both. So it's the solution to the system. All right, again, to reiterate all of this, right? A system of equations is a set of more than one equation. So whenever they give you more than one equation at the same time, the whole purpose of that is to find out if they are crossing, okay? The point of intersection of the two graphed equations is the solution. So the point where they're both crossing, that's called the solution. All right, here we go. Let's do line A first. So for line A, give me the y-intercept, the origin, right? So 0. And what about the slope? I think this is the part where you guys are like struggling to find slope, okay? So you're just going to have to pick your y-intercept, and then just pick any other perfect little point on the line. So like I see another perfect little point right here. And then just rise and run. So how many?
Rise 2, run.
Rise 2, run 3. Very good. So rise 2, run 3. Once you have that, you've got the M, you've got the B, so then you've got the numbers to write the slope-intercept. What's it going to sound like? Y equals what?
Y equal
2
2
x. And then do I have to put plus 0?
No.
No, you can leave it like that. Good. Now let's go to line B. What's the y-intercept of line B? 2. I'm going to pick another perfect little point. I like this one. And I'm going to rise how many?
rise 1,
1.
3.
And run 1, 2, 3. Very good. So what's my equation going to look like? Y equals what? 1 over 3x plus 2. Very good. And then it says, what is the solution to this system? What is that fancy for? What are they asking you for? Where are they crossing? Very good. So where are they crossing? Very good. Right here. This is the solution. And what ordered pair is that? 6, 4, right? I heard some of you say it. And no, we're not going to prove our answer. There's our proof. It is the point of intersection. So we can just write that. Point of intersection. And the bottom, it's just really easy.
No one was there. I'm sorry.
So we're really going to skip it. The whole purpose of today's lesson is if I give you 2 equations, A, can you graph them, right? Or they already give you the graph, can you give me the equations? And then determine whether they're crossing, right? Because that's called the solution. Or whether they're not crossing at all or whether they cross everywhere. So that's the whole purpose of systems of equations. Turn it to the back. And that's just more of exactly what we've been doing right now. So let me ask you something. And we can write this on the first page that had nothing on the back. Right here, make a little note because your independent practice has some problems like this, okay? Huh? Yeah, check it out. Point number 1 to remember. If the equations, and write this down, if the equations cross once, then we say the system has one solution. If the equations do not cross at all, then how many solutions is it going to have? None, because they don't cross, right? So we say no solution for lines that don't cross. And what do we call those lines? What do we call the lines that never cross? That never meet each other? Parallel, right? So these are your parallel lines. So if you see a picture of parallel lines, they don't have a solution because they never intersect, right? Now, I did teach you that your elementary teachers lied to you, right? And they just said, oh, they're just lines that never meet. But why, right? Well, because parallel lines have the same slope, but a different y-intercept. So for example, y equals 2x minus 3 and y equals 2x plus 10. As soon as you see that they have the same slope, but they have different y-intercepts, you need to train your brain up. Those are parallel. They're never going to meet. So they're going to have no solution. Okay? And who remembers from the video, how do you end up with infinite solutions? Yeah, they ended up being the same exact line. They were just written differently, but they're the exact same thing. So they land right on top of each other. So they're going to cross everywhere. Okay? So for example, if I gave you this, so they will cross everywhere because they are the same lines. So if I gave you y equals, let's see, 4x minus 5, and then I got fancy and gave you this one right here, even though they look a little different, what do you know about 20 over 5? What do you know about this guy right here? Do you know what 20 divided by 5 is? Because remember, we have to simplify fractions whenever we can. It's 4. So you end up having the same slope, and you also have the same y-intercept. Well, then they're the same line. They're going to cross everywhere. Okay, so that's why we say that one has infinite. They cross everywhere. Okay? Questions there? So now I'm going to give you a practice worksheet, and you're going to try, I think there's maybe like 6 questions. It's not a lot. 6 questions. If you don't finish, that's the part that you take for homework, okay? But remember, tomorrow when you come in, Mr. Gonzalez is going to check. A, did they turn in the video? B, do they have both of these notes written? And do they have it, taped down to their spiral? Because I don't want it just in your backpack. Make sure you have it somewhere saved. And then 3, did they complete the independent practice, which he's passing out right now? Okay?